Finally, what is an inflection point? An inflection point is a place on the graph where the concavity changes. So once you learn to recognize concavity, you can see these pretty straightforwardly. Just look for the place where the curve goes from being concave up to concave down, or vice versa. So in looking at this one, curve is concave down, concave down, concave down, concave down, concave down. And somewhere around here, it switches to being concave up. Curve switches to being concave up, and then it's concave up, concave up, concave up, concave up. Somewhere around here, it switches to being concave down, and then we do this continue, and it's concave down until about here, it's concave up, and then it's concave down until about, it's concave up until about here, it's concave down until about here, it's concave up. So this has 5 inflection points that you can recognize just by using your eyes for what looks like concavity and seeing, does it change from concave up to concave down or vice versa? Now, how do you find concavity and inflection points using second derivatives? So we're going to have a sign chart process. So let's look at a pretty basic example where we have f of x is equal to x to the 4th minus 3x squared. And the first thing we're going to do, because we're dealing with concavity and inflection point, okay, so I'm setting 24x squared minus 6 equal to 0. So I'm adding 6 to both sides here because I can isolate the x squared, and I'm going to add 6 to both sides and cancel that out. And as I do this algebra, I get 24x squared is equal to 6. Divide both sides by 24. Okay, that simplifies to be x squared is equal to 1/4. And when I take the square root here, I get that x is equal to positive or negative 1/2. So these are places where I know that f double prime is equal to 0. And now what I'm going to see is what happens between these places. So I'm going to make a sign chart, and I'm going to be looking for, so I'm going to switch to the handwritten view because it's easier to see. But I've looked at my places where x is equal to positive or negative 1/2, and now I've created a number line where those are dividing points on the number line. So I have 3 intervals from negative infinity to negative 1/2, negative 1/2 to 1/2, and 1/2 to positive infinity. And what I want to do is I want to pick a test point from each region. So from negative infinity to negative 1/2, I could test lots of things, but let's do x equals negative 1. Here in negative 1/2 to 1/2, I could do x equals 0. And here from 1/2 to infinity, I could do x equals 1. Now what I want to do is evaluate f double prime at the test point. So I'm going to have f double prime of negative 1 is 24 times negative 1 squared minus 6, positive 18. So my conclusion about the sign of f double prime of x here would be that f double prime of negative 1 is positive. And so that's actually a stand-in for this entire region. If f double prime of negative 1 is positive, that means f double prime of x is positive everywhere throughout here. So the concavity of f of x then is also determined. We're looking at f of x being concave up on this entire region. Now we're going to do the same reasoning with x equals 0. So f double prime of 0 is equal to 24 times 0 squared minus 6 is negative 6, and that is negative, so f double prime of 0 less than 0, which means that on this entire interval, f of x is concave down. And finally, at x equals 1, we plug that in, and it's the same calculation over here because of symmetry, so we get positive 18. So f double prime of 1 is positive. This means that f of x is concave up on this entire region. So the important thing is to find the places where f double prime of x is equal to 0. Divide your number line into intervals based on that. Choose a test point from each interval. Evaluate f double prime of x at that test point. Determine the sign of f double prime of x, and then determine the concavity of f of x. So our conclusion here is that the original function f of x has inflection points at x equals 1. So finishing this up, we see that f of x was concave up on negative infinity, negative 1/2, and 1/2 infinity, and that f of x is concave down on negative 1/2, 1/2. Following the sign chart process for f double prime of x gives us information about the concavity and inflection points of the original function f of x.